Get started. Okay, in today's lecture, I'm going to talk about link changing, which is the second essential model. We talked about car following models in the last lecture, and in this lecture, I'm going to talk about this link changing model. So you will know both models that are essential to traffic simulation. This is the outline of today. I want to first talk about link changing concepts and then talk about some algorithms. I want to talk about the application of link changing in these 5 simulation tools. No, only 3. These two are, for these 2 tools, there is a strike-through line, which means I'm not going to talk about them today. The reason that I'm not going to talk about parametrics is very simple, and it's very close to M-sum. And transient is using cellular automata, which I want to have a new lecture to talk about it. So I will only talk about 3 algorithms in M-sum, V-sim, and COSIM. And the last one, LSA, lane selection algorithm, is the recent algorithm developed by MIT. And I think it's very different from those previous ones, so I want to introduce it in the end. Now let's go to the concepts. This is important. Let's consider this subject vehicle. This subject vehicle wants to change its lane from this one to that one. And we can call this a target lane. Now, if we have a vehicle here and a vehicle here, then this vehicle can be called a lead vehicle, and this vehicle can be called a lag vehicle. Then we have this lead gap, and lag gap. And this whole gap is called an adjacent gap. And this is the traffic direction, of course. This lag vehicle in V-sim is also called trailing vehicle. So pay some attention to these concepts, especially lag vehicle and lag gap, and lead vehicle and lead gap. And let's imagine this here is another vehicle. I don't have any term here to describe that vehicle, but I would call it downstream vehicle. Downstream vehicle. Lane changing has 2 types. The first type is called mandatory, which means you make the lane changing because you want to turn or you want to reach another lane. These are mandatory because if you don't change lane, then you won't be able to reach your destination. And it's also called MLC. The second type is discretional lane changing. In this type of lane changing, you change your lane because you want to get a better traffic condition. For example, you want to pass another vehicle, or you want to yield to a fast vehicle. You want to switch to a slower lane to let a faster vehicle go through. That's called discretional lane changing. Understand this? Mandatory and discretional. They are easy to understand. Now I want to talk about the importance of lane changing. Let me just show you these 3 concepts. They are very similar to car following. The first reason we want to have lane changing is because we want to distribute vehicles to different lanes. We want to utilize all the lanes. That's the first reason. The second reason is we want to avoid collision or dangerous traffic situation. So when the vehicles are changing their lanes, they will interrupt the existing car following condition, and we want it to be safe. That's the second reason. And the third reason is we want to replicate realistic vehicle movements. That's similar to the slides in car following. But I want to have quick questions to warm up. So let's think of this question. Will the choice of lane changing model affect road capacity? I just replace this, the car following model by lane changing model. So this is first question. Think about it. If I use different lane changing models, will that affect road capacity? Can anyone guess? Guess. Yes or no? Yes. Yes. As I mentioned in, before midterm, I talk about this lane changing thing. If the lane changing model is not working very well, then the segment or the link may be blocked because some vehicles could not go to their destinations. So the choice of lane changing model will affect road capacity. This is different from car following models. Then certainly, naturally, we come to the second question. How can you validate a lane changing model? If you can remember, in the car following model lecture, we said the choice of car following model will not affect road capacity. Then we can only use time-space diagram to validate it. But in this case, it will affect road capacity. It will affect the traffic flow. It will affect a lot of things. This means this is good news for us because then we can use a lot of data to validate this model. Because it can affect them, then we can use them to validate it or calibrate it. So this is different from the car following model. I want to emphasize this. Do you have a question about this? If no, then let's talk about the decision tree. So if we consider lane changing decision-making process, we can divide it into two levels. In the first level, we have a lane choice model. We want to choose the lanes we want to stay, the vehicle wants to stay. Do we want to keep in the current lane, or go to the left lane, or go to the right lane? So we compare these three options, then we have a choice. This is used for both mandatory and discretional. But let's think about the discretional one. The vehicles just want to change lanes because they want to reach better traffic conditions. We first have a lane choice. Then with each choice, after we get a choice, we then check the gap acceptance model. We use gap acceptance model to check if there is a sufficient gap that the vehicle can move to that lane. If the vehicle, for example, if the vehicle prefers going to the left lane, and then it checks the gap, if the gap allows, then it changes left. Otherwise, it has no change. This decision tree is very easy to understand, I think. Remember, we have two models, lane choice model and gap acceptance model. Any question? Okay, so those were basic ideas, basic concepts about lane changing. Now let's go through the algorithms. I picked MSUM as the main software to talk about today because it's the most complex one. In MSUM, a road segment before an intersection or before a junction will be divided into three zones. In the first zone is the furthest to the node or to the junction. And in this zone, MSUM defines the vehicles only change their lanes because they want to reach better traffic conditions. So in this zone, the discretional lane changing is the most important one. Understand? In this zone, the vehicles change their lanes for better traffic conditions. But after the vehicle reaches this zone, the second zone, then the vehicle starts to consider about the next turning movement. So for example, if a vehicle is here, then in this zone, it will try to go to the right. So this zone is for mandatory lane changing, the second zone. And in the third zone, all the vehicles are still performing the mandatory lane changing. But these two zones are different in that in this zone, only the vehicles that want to change their lanes are modeled. In this zone, other vehicles will be cooperative. So in this zone, if the vehicle cannot find a sufficient gap, then it stays, just keep moving. But in this zone, if the vehicle cannot find a sufficient gap, then some other vehicles will yield to it to make a sufficient gap. So in this zone, the vehicles are cooperative. And in this zone, if a vehicle cannot go to its destination lane, it will slow down or even stop. But in this zone, it will keep moving. So let me summarize. This zone is only for discretional lane changing. This is mainly for mandatory lane changing. And the vehicles will not slow down. And the vehicles are not cooperative. In this zone, all the vehicles are making mandatory lane changing. And they are cooperative. And they will slow down and stop. 3 zones. These 3 zones are defined by a time. You can specify a time of each zone, the time headway. So for example, if you specify this to be 2 seconds, and this to be 2 seconds, for example, then this time headway has to be converted in Amazon to a distance. This dm is the distance in meter. This is the specified time headway. So dt, you gave Amazon this dt, and it will calculate the actual length called dm. The dm will be equal to the dt multiplied by the speed limit, of course. But another thing is speed limit divided by the desired speed of each vehicle. So for different vehicles, this zone length will not be the same. Each vehicle has its own zone length. So they won't be the same. Understand this? Now, I show you this equation only wants to show you each vehicle has its own zone length according to its desired speed. Now, in Amazon, you want to change these parameters in the road type dialog. So this is defined.